grade 9 students. Today's session is to solve typical exercises on electrochemistry. The materials needed are chemistry guide, chemistry notebook, and a pen. Open please your support guide on page 9091 and follow me in exercise 18. Some solutions used in galvanic cells are colored due to the presence of certain ions in the solutions. For example, nickel nitrate solution is green in color due to the presence of nickel ion and I2+, whereas copper sulfate solution is blue due to the presence of copper ions. Into a beaker containing a copper nitrate solution, blue in color, and a thermometer indicating 21 degrees, a nickel and I strip is introduced. After a certain time, the thermometer indicates 23 degrees. In fact, a redox reaction takes place which is represented by the given equation. E. An I plus Cu2 plus give an I2 plus Cu. Number 1. Identify the reducing agent. As you can remember, the reducing agent is the species that undergoes oxidation half reaction. Now, how can I know which species undergoes oxidation half reaction in this reaction? I can know according to the variation in the oxidation number. As you can see here, nickel, its oxidation number was 0, whereas when it becomes an I2+, its oxidation number becomes +2. So here, an I is the reducing agent since its oxidation number increases from 0 2 plus 2, so it undergoes oxidation half reaction. Number 2, the oxidation half reaction is an I gives an I2 plus 2 electron. Deduce the reduction half reaction, and from the previous slide, the redox reaction is an I plus Cu2 plus give an I2 plus Cu. And you have given from this part the oxidation reaction as we read it. In order to deduce the reduction half reaction, and you have the redox reaction and one of the other half reactions, the first step to do is to reverse one of the half reactions that are given. Here in the exercise, the oxidation half reaction is given, so we should reverse this oxidation half reaction. It will become an I2 plus 2 electron give an I. Now, we should add the redox reaction with the reverse oxidation reaction. So my work is on the reverse oxidation reaction and not on the oxidation half reaction that is given. Now I should add these two reactions. First of all, we can see that the an I can cancel each other, and we can see that an I2 plus they can cancel each other. So what will remain here? The reduction reaction is Cu2 plus 2 electrons give Cu. This is the reduction half reaction. Number 3, give the energy transformation that took place. Into a beaker containing a copper nitrate solution blue in color, this was the given, and a thermometer indicating 21 degrees, a nickel and I strip is introduced. After a certain time, the thermometer indicates 23 degrees. So as you can see here, the thermometer was 21 degrees, then it indicates 23 degrees. So what happens here? The thermometer heats up. So the energy transformation is, the energy is transformed from chemical energy into heat or thermal energy. It's required to construct galvanic cell G whose overall reaction is represented by the same equation, an I plus Cu2 plus give an I2 plus Cu. The adjacent schema shows a half compartment of galvanic cell. Half of the galvanic cell is shown here. Copper strip is dipped in copper 2 plus solution which has blue color. The following materials are available. We have beakers 250 ml, Zn2 plus solution, Cu2 plus solution, and I2 plus solution, iron wires, connecting wires, strips, Cu strip, Zn strip, and an I strip, a voltmeter, and a U-shaped tube containing an electrolyte, which is the salt bridge. Number 4, list the materials needed to complete the construction of the galvanic cell. We want to complete it. We have the half compartment. I want the other half compartment to complete it and become a galvanic cell. And the reaction is between Ni and Cu2+. So what we need is another beaker, 250 ml. We have the copper strip. Now we need the other compartment, which is the Ni strip, should be dipped in Ni2+ solution because every strip is dipped in its own solution. U tube containing electrolyte, which is the salt bridge, which is the orchestra of this galvanic cell. Without it, the galvanic cell will not work, and the connecting wires and the voltmeter. Number 5, Ni is the anode of this cell. Justify. As you can remember, the anode is the species that undergoes oxidation half reaction. And the given oxidation half reaction is Ni gives Ni2+ plus 2 electron. So nickel is the anode since it undergoes oxidation half reaction. Number 6, explain why after a certain time the intensity of the green color of the nickel solution increases, whereas the blue color of the copper solution decreases. As you can remember also, the intensity of the solution depends always on the amount of ions inside it. So, Ni undergoes oxidation, so it loses electrons and it transforms into Ni2+. That goes into the solution. Now, the amount of Ni2+ will increase in the solution. Thus, the amount of ions increase and the intensity of green color will increase since the intensity depends on the amount of ions. Whereas Cu2+ undergoes reduction by gaining electrons and transforms into Cu. So now the amount of Cu2+ is decreasing and becoming Cu, which will make a deposit on the strip. Then the intensity of the blue color will decrease since the intensity of the color depends on the amount of the ions in the solution. As the amount of ions decreases, the intensity of the color will also decrease. Number 7, choose among the following schematic representations the one that corresponds to the cell. A, Cu2+, Cu, salt bridge Ni and Ni2+. B, Ni and Ni2+, salt bridge Cu2+, Cu. C, Cu, Cu2+, salt bridge Ni2+, Ni. In order to remember in general how we can make schematic representations of a galvanic cell, we should start with the reactant, then the product of the anode, dash salt bridge, dash reactant product at the cathode. So as you can remember, the anode was the Ni. So it was Ni as a reactant, then it becomes Ni2+ as a product, dash salt bridge, and the cathode is the Cu. It was as a reactant Cu2+, then it gains electron to become Cu, so the correct answer is part B. Now, number 8. A salt bridge is used in constructing the galvanic cell G to close the circuit. Give another reason for the usage of the salt bridge other than it makes the circuit a closed circuit. This is for study. Their role is to maintain the electroneutrality of the two solutions in the half cells. Exercise 19, page 91-92 in the support guide also. An electrochemical cell converts the energy of a spontaneous redox reaction into electricity. It's used as a source of electric energy. Document 1 represents 3 electrochemical cells G1, G2, and G3. The symbolic representation of an electrochemical cell G4 between Mg and Zn is Mg, Mg2+, dash salt bridge dash Zn, Zn2+. The electrochemical cell G1 is said to function. The equation of the reaction that took place is 2Ag plus Cu give 2Ag plus Cu2+. Number 1. What is the cathode of the cell G1? Justify referring to the schema of G1 in document 1. As you can see here from the schema, we can see the flow of electrons. We know that electrons flow usually from the anode part to the cathode part. So here, the cathode of this cell is Ag strip because the electrons move from the anode to the cathode. Now, number 2. Show using oxidation numbers that the above reaction is a redox reaction. 2Ag plus Cu gives 2Ag plus Cu2 plus. As I told you in the previous videos, you should not take into consideration neither the coefficient nor the subscript while you are calculating the oxidation number of an element inside the equation. So the oxidation number of Ag plus is plus 1, Cu is 0, Ag is 0, Cu2 plus is plus 2. The oxidation number of Ag plus decreases from plus 1 to 0, and the oxidation number of Cu increases from 0 to plus 2. Then, because the oxidation number of copper increases from 0 in Cu to plus 2 in Cu2 plus, so it undergoes oxidation half reaction. The oxidation number of silver decreases now from plus 1 in Ag plus to 0 in Ag, so it undergoes reduction half reaction. Since there are oxidation and reduction reactions, so it's a redox reaction. Number 3, specify the species that undergoes oxidation. Write the half equation that took place. So the species that undergoes oxidation is the species that its oxidation number increases during the reaction. So Cu undergoes oxidation since its oxidation number increases. Its half equation is Cu gives Cu2 plus plus 211. Number 4, deduce the oxidizing agent. The reaction is a redox one where a species undergoes oxidation and the other undergoes reduction. Since Cu undergoes oxidation, so it's the reducing agent, thus Ag plus is the oxidizing agent. During the functioning of the cell G2, the quantity of the Cu2 plus ions in the solution varies. Number 5, describe while justifying the variation of the quantity of Cu2 plus ions in the solution during the functioning of the cell. So, we can say, when the cell is functioning, Cu2 plus ions gain electrons and transform into metallic Cu that deposits on the Cu strip, increasing its mass, so the quantity of Cu2 plus ions decreases with time. Number 6. Verify that the reaction in this cell is due to an indirect contact between the reactants. The reaction between the reagents in this cell is indirect because they are placed in separate compartments, each in its own beaker. The salt bridge of the cell G3 contains potassium nitrate K plus and O3 minus as a jellified electrolyte. 6. Rank the metals involved in the 4 above cells in an increasing order of their reducing power. First, to start with G1. In G1, as you can see here, Cu has more reducing power than Ag because electrons flow always from the anode to the cathode, and the anode always has more reducing power than the cathode. So Cu, because it's the anode, it has more reducing power than Ag. So if we want to put now Cu and Ag in an increasing order of their reducing power, we can put the Ag here is less than Cu. Because whenever we are saying reducing power, we means that species that undergoes oxidation half reaction. So Ag has less reducing power than Cu. In G2, Zn has more reducing power than Cu here because Zn, its mass is decreasing, so it's losing electrons, whereas Cu, its mass is increasing, so it's gaining electrons. So Zn is the anode and Cu is the cathode. Then Zn has more tendency to lose electron than Cu, so we can put it here. No, Zn has more tendency to lose electron than Cu. This means that Cu has less tendency to lose electron than Zn. Now in G3, Mg has more reducing power than Cu. Why? Because as you can see here, the negative or the anion of the salt bridge migrates toward the Mg strip. So in order to make a balancing, the salt bridge is sending negative charges. This means that the amount of positive charges is increasing in order to make compensation and electron neutrality. So if the amount of positive charges is increasing, this means that the amount of ions is increasing. So Mg becomes Mg2 plus, so it's losing electrons. Then Mg is the anode. So Mg has more reducing power than Cu. Now, Mg has more reducing power than Cu and Zn has more reducing power than Cu. So what should we do? We should put Zn then Mg or Mg then Zn because both have more tendency to lose electron than Cu. We should into consideration now G4. G4 it's between Mg and Zn. The representation starts with Mg, which is the anode, and ends with the cathode. So Mg is the anode here and Zn is the cathode. Mg has more tendency to lose electron than Zn. So we can put it at the end of the axis. Number 8, explain why NO3 minus nitrate ions in the salt bridge move to the magnesium half cell. In the anode half cell, Mg atom is oxidized in the solution, so the quantity of positive charges, Mg2 plus, increases. To keep the solution electrically neutral, the nitrate ions migrate towards the solution of this half cell. Number 9, give the symbolic representation of cell G3. The schematic representation of the cell is always anode, salt bridge, cathode. And we said that between Mg and Cu, Mg has more tendency to lose electron than Cu. Then it should be at the part of the anode. So Mg, it's the reactant, gives Mg2 plus, which is the product, dash salt bridge, dash Cu2 plus was the reactant and gives Cu as a product. Hope you are interested in these exercises.